You might be interested in this concept of ground, especially if you've seen circuits written more like circuits with the sense of, something goes around in a circuit, and that would typically have a battery. So let's do this sort of battery equivalent of this circuit. So here's a battery. Might as well be a 5-volt battery to match this. And our same old 1 kilo ohm resistor and the phototransistor, and it lights up just fine all the same. So what's the relationship between these two things? This one seems kind of open, and this one is literally in a closed circuit. We can pick any point on this circuit and say that point is going to be referred to by the special name ground. In fact, what we've done is we've done it as this point. We've said that's defined to be ground. And having done that, our power supply that's built, this battery, is now replaced by something that is built into your breadboard. That 5-volt rail has always got 5 volts relative to ground on it, so we don't have to show anything like a battery explicitly. In fact, all we have to do is say, this other rail up here, that's connected up to our power supply at plus 5 volts. So those two circuits have that equivalent, and ground is just our simple designator that we're going to call, by definition, we're going to say that the absolute voltage at that point called ground is 0. So I could make these measurements, as I did, 1.6 volts across the LED and 3.4 volts across the resistor. That's a 2-point measurement using a DVM. Or when I measure any point in this circuit with a single-point measuring device like a scope, I'm measuring that voltage with respect to ground. And so when you see a symbol like this, it often just means I've measured this voltage. I'm telling you about the voltage. It doesn't necessarily mean that there is literally a voltmeter there. So somebody might write 3.4 volts. And what they're telling you is there are 3.4 volts across this resistor.